So we've just talked graphically about how to figure out the cross product. How do we actually figure out the cross product if we're given the components of the vector? How do we compute the cross product with components? So there are a number of different ways to represent this. I will use a representation I think is sort of handy um, that applies when you're talking about the Cartesian coordinate system, although certainly you can use similar types of representations in other coordinate systems. So I'll first draw this little diagram. So we've got I hat, j hat, and k hat. And what this diagram tells you is the sort of directionality of the right-hand rule for cross products. So what this says is that I hat cross j hat is k hat, j hat cross k hat is I hat, and k hat cross j hat, or cross I hat, is j hat. Now, if you think about the right-hand rule, it's pretty clear that they're actually, the order matters. Like if we come back over to this diagram, when I'm taking the cross product of A cross product B, I'm rotating A into B, and so righty-tighty that A cross B goes into the page. If I were doing B cross A, I'd have to line up the screw with B and then rotate into A, lefty-loosey, B cross A would come out of the page. So the direction of this, the clockwise direction of this diagram is important. J hat cross I hat is what? Well, it's minus k hat. You know, I hat cross k hat is minus j hat, and k hat cross j hat is minus I hat. Okay. Now, once you've got the components, it's actually relatively easy to just use distribution to figure out what the cross product is. So if I say that A vector is 3 times I hat plus 4 times j hat, and B vector is 2 times I hat plus 1 times j hat. What's A cross B? Well, A cross B is 3 I hat plus 4 j hat cross 2 I hat plus 1 j hat. 3 I hat cross 2 I hat, well, I hat cross I hat is 0, right? Because sine of theta is theta 0 between I hat and I hat. So this term gives me 0, right? As does 4 times j hat cross 1 times I j hat. That gives me 0. On the other hand, 3 times I hat plus 1 cross 1 times j hat is 3 times I hat cross j hat, so that's 3 times k hat. And 4 times j hat cross 2 times I hat is 8 times minus k hat. And so in this particular case, I'm going to get 3 times k hat minus 8 times k hat, or minus 5 k hat. Let's see if that actually makes sense. So A looks like this, 3, 4. So there's what A looks like. B is 2 and 1. There's B. When I cross A into B, I'm going to be going into the page. That makes some sense.